Hey 7th graders, welcome to your second video. In this video we're going to be actually talking about the percent and estimation of a number. So we're going to kind of be doing what we did in the previous lesson where we take a percent of a number, but now we're going to do it by estimation purposes. So our objective is to estimate the percent of a number. Our goal is to try to do a lot of this without calculation, so without actually using a calculator figuring out our answers. So we might break up percents. We're going to look at percents that are bigger than 100 and less than 1. So that's what we're going to be doing in this lesson. Let's get started. In our first example, we're going to be looking at an estimation of a problem about how much money that somebody might have paid off in their loan. So here, Jody has paid 62% of the $500 that she owes for her loan. So we know she owes $500. She's already paid 62%. We need to estimate what 62% of 500 is. So an estimate means don't give the exact answer. Tell me about how much she has paid. Well, 62% is probably really close to 60%. So she has paid 60 out of 100%. Since I have a 0 on top and bottom, I'm going to cancel that out. That means that she has paid 6/10 of her loan. Okay, so 6/10 is the number I'm going to be using. She's paid 6/10 of 500. I can put 500 over 1, kind of what we did in the past. 6 times 5, that's 30. Add 2 zeros, that's 3,000. 10 times 1, that's 10. Since I have a 0 at the end, I can go ahead and cross that out. And I can see that she has paid 300 over 1. So in this problem, Jody has paid about $300. She's actually paid more than $300 because we took the percent and we rounded it down. If we would round the percent up, she's paid less than that amount. But we said 62% is close to 60%. We made it 60 out of 100, and then we multiplied it like we did in the previous lesson. So in this problem, what we're going to do is we're going to round our percent or round the number so that way we can multiply them a little bit easier. So this would be our answer to question number 1. Let's keep moving. Alright, in this example, we're going to estimate 61% of 440. So we're going to try this kind of similar to what we just did. We're going to first start by changing our percentage to something that's probably easier to work in, making it end in 0. So I'm going to say that 61% is about 60%. And I'm going to make 60% a fraction by putting it over 100. So I got 60 over 100. Since I have 0 on top, 0 on bottom, I can go ahead and cancel that out. And I got 6/10. Okay, so I have 6/10. I don't really mind the number 440. I could maybe make it easier to work with, but 440 is an okay number. So I'm actually going to multiply by 440 over 1. So I'm going to actually do the multiplication of 6 times 440. I'm going to do that kind of old-fashioned way. So I'm going to times it by 6 here. 6 times 0, that's 0. 6 times 4, that's 24. Carry the 2, drop the 4. 24, 26. Alright, so I got 2,640. And 10 times 1, that's 10. Since I have 0 on top, 0 on bottom, cancel that out. We're looking at about 264. So 60% of 440 is about 264. So this is a number that's close to our estimate. Now what we did was we rounded 61% to 60%. We left 440 alone. We could have rounded it up to maybe 450, made it a little bit easier to work with. We did the math without a calculator. Our goal is to try to do a lot of this without a calculator so that way we can either round up or round down. Let's keep going. In example 3, we're going to be reading a real-life problem that maybe you're going to separate pizza with the price of pizza with your friends. So it says Marita and her 4 friends ordered a pizza. The pizza cost them $14.72. she is responsible for 20% of the bill. So if you get a pizza with 5 of your friends, or if with 5 people, you're responsible for 20% if you're going to divide it equally among each other. How much will she need to pay? So our job is to figure out about how much money is Marita going to pay in this problem. Well, we know that she's going to pay 20% of 1472. Now, 1472 is a decimal and it's a little harder to work with, so what we could do is we could round one of these numbers or round both of these numbers. In this case, 20% is 20 out of 100, and that's a good number to have. Since I have 0 on top, 0 on bottom, go ahead and cancel that out. So she's going to pay 2 out of 10 times. Now, this is where I might want to change this. Instead of using 1472, we might want to change this to $15. Because, I mean, the price of the pizza is about $15. So we're going to put 15 over 1, and we're going to multiply straight across. 2 times 15, that's 30. 10 times 1, that's 10. And since we have 0 on top and bottom, go ahead and cancel that out. 3 divided by 1 is 3. So Marita is about responsible for about $3 of this price of the pizza between her and her friends. And 3 times 5 would be 15. They'd be able to cover the price of the pizza with $15. So about $3 is what she should chip in for the price of the pizza. Let's keep going. In example 4, we're going to talk about minting coins. So it says Milena calculated that 40% of the coins in her collection were minted before 1964. So the date on the coin is before 1964. If there are 715 coins in her collections, which is a really big collection, about how many of those coins were minted before 1964? Since the question asks about how many, we aren't given exact answers, we're estimating. So we're going to round the numbers if we have to. Well, we know that we're going to figure out what 40%, because that's our percentage, of 715 is. So we're going to figure out about what 40% of 715 is. And again, the key word is about. So we don't need the exact answer, we need to round that number. So I'm going to say that we have 40, which is 40 out of 100. 0 on top and bottom, cancel it out. I'm going to look at 4 tenths. I'm going to say that 715 is about the number 700. So we're really taking 4 times 700, and we're going to put that 700 over 1 to make it a fraction, and we're just going to multiply straight across. 4 times 700, that's 2800. 10 times 1, that's 10. Since I have 10 on top, I have a 0 on top and bottom at the end, go ahead and cancel that out. We're looking at about 280 coins. So out of our 715 coins, about 280 of those coins were minted before 1964 based on this problem and based on the fact that we estimated, which means we either rounded up or we rounded down on either our percent or our number. Let's keep going. In example 5, we're going to be estimating 122% of 50. So now we're looking at percents that are bigger than 100. So that's what we're going to be doing in this problem. Now, what we're going to do first is we're going to break up 122% into 2 different percents. And since we're estimating, we're going to round those numbers. I'm going to say that 122% is about 100% and 20%. So I'm going to look at 100% and I'm going to look at 20% of 50. Now, if I had 100% out of 100% of 50, all I got to do now is just multiply straight across, but since I have 0 on top and bottom, I'm going to cancel out those zeros, and I'm really looking at 1 times 50, that's 50. 1 times 1, that's 1. So if I had 100%, I would have 50. If I have 100% of 50, I do have 50. So 50 is 100% of 50. Now I need to figure out what 20% is. So I put 20 over 100. Since I have a 0 at the end, I'm going to go ahead and cancel that. I'm looking at 2 tenths times 50. Put that over 1. 2 times 50. That equals 100. 1 times 10. That equals 10. And again, I have zeros at the end. Cancel those out. And I got 10. So 100% is 50. 20% of 50 is 10. Add those together, 50 plus 10, 120% of 50 equals 60, and that's my answer. All I did was add those two numbers together, and that gives me my answer. The 50 represents 100%, and the 10 represents 20%. So 100 plus 20, 120. 120% of 50 is 60. That's our answer to this problem. Let's do another one just like this. In example 6, we're going to be finding 173% of 60. And so I'm going to kind of approach it in the same sense. First thing is I'm going to round 173% to probably 170%. So I'm going to break it up into its 2%. I'm going to have 100% plus 70% would be about that number. So I know that 100% of 60 is 60. So 100% of 60 equals 60, because we just figured out in the previous problem that 100% of 50 was 50, so 100% of 60 is 60. So the only thing we've really had to figure out is what's 70%, which is 70 out of 100 of 60. And we put 60 over 1. Again, since I have 0 on top and bottom, I can cancel that part out. 7 times 6 is 42, add a 0. 10 times 1 is 10. And now, since I have 0 on top and bottom at the very end, go ahead and cancel that out. 42 divided by 1 is 42. So I know that 70% is 42. I know 100% is 60. So I'm going to add 60 to this, and I get 102 would equal 170% of 60. So this is about the answer that I'm looking for. 102 would be about 170% of 60. In example 7, we're looking at a really long word problem. It says there are 789 students at Washington Middle School that are in 7th grade. In example 7, we're going to be solving a problem that talks about students traveling across the ocean and going to different countries. So it says there are 789 7th grade graders at Washington Middle School. About 1/4% of the 7th graders have traveled overseas. What is the approximate number of 7th graders that have traveled overseas? So our job in this problem is to figure out how many 7th graders out of that number have went across the ocean to another country. Now, look at the percent they give us. They give us 1/4%. Well, 1/4% of what number? 1/4% means 1/4 of 1%. It's not even a whole percentage. 1/4 is a fraction of one whole. So 1/4% is 1/4 of 1%. So what we have to do is we have to figure out what 1/4 percentage of this number is. Before you do this, though, one of our first steps is if you have a percent less than 1, we need to find 1% of the number first. So before we actually solve this problem, we need to figure out what about 1% of that number is first. Well, 1% is 1 out of 100. And we're going to multiply it by the number that we have. Well, 789 is about 800 students. So I'm going to put 800 over 1. 1 times 800, that's 800. 1 times 100, that's 100. Since I have zeros on top and bottom at the end, I can cancel those out. And 8 divided by 1 equals 8. So 8 students represent 1%. But I don't want to know what 1% of the students are doing. I want to know what 1/4 of a percent of the students are doing. So now that we have 1%, we're going to take this 1%, which is 8, and we're going to multiply it by 1/4. So we take 1/4%, and we times it by our 8 students, which represent 1%. 1/4 times 8, I'm going to go ahead and put 8 over 1. 1 times 8, that's 8. 4 times 1, that's 4. 8 divided by 4 is 2. So, if there were 800 students in a school and only 1/4% of those students traveled overseas, then that's really only 2 students have been to another country across the ocean. First, we found 1% of the big number, and then we took that number times 1/4 percentage. We will practice this a little bit more in class. Just understand if your percent is ever smaller than 1%, like it's a fraction of a percent, then what we have to do is find 1% first, and then take our fraction of that percent times our number that we get. Let's try another one just like this. In example 8, we have about 1/3% of Smithsville's 1,500 adult citizens are going to be attending the upcoming pop concert. So there's an upcoming pop concert, and about 1/3% of 1,500 adults in this city are going to be going to that. Our job is to figure out about how many of those adults are actually going to that concert. So before we actually begin, we have to figure out what 1% of the number is, because 1/3% means 1/3% of 1%. So we have to figure out what 1% is. Well, 1% is 1 out of 100 times. Now, 1,500 is a good number to use, so we're going to leave it as 1,500. We're going to put that over 1, and we're just going to multiply straight across. 1 times 1,500, 1,500. 100 times 1, 100. Zeros on top and bottom, cancel out. So we know that 1% of those adults would be 15 of those adults. So 15 is 1%. So we know that 15 represents 1% of the adult population. Now we have to take 1/3 of 15%, or 15. So we're going to take 1/3 of 15 to figure out how many adults went to this concert. 1 times 15, that's 15. 3 times 1, that's 3. And 15 divided by 3 is 5. So in total, just about 5 adults went to this concert. If there's 1/3% of 1,500 people that went to the concert, that would be 5 adults. This is how you solve these problems that deal with percents that are less than 1%. So we've looked at percents more than 100, we looked at percents less than 1, and we've looked at percents where we round an estimate. We got 2 more examples to do, maybe 1, we'll see how it goes, and then we're done for this lesson. Alright, I decided after looking at the next 2 questions, we're only going to do 1 question, so hopefully you guys are pretty happy about this. This will be our last question for this lesson. So it says, example 9, last year 639 students attended a summer camp. Of those who attended this year, 0.5%, 0.5, so less than 1%, also attended summer camp last year. About how many attended summer camp 2 years in a row? So we have something that's less than 1%. We have 0.5%. So what we're going to do is we're going to round numbers to make it easier to work with. Since it's 0.5%, we might want to change that percent to a fraction, just because we've noticed that when we're working with fractions, it's actually pretty easy to find the percent of a number if we start by doing a percent of 100, canceling out our zeros, multiplying across. We're getting our answers without any calculators. So we can still use fractions. So we might want to change 0.5% to a fraction. Well, this is actually 0 and 5/10. So we could say that this is 5/10 of a percent. So that's what we're really figuring out, is 5/10% of those students went to the summer camp 2 years in a row. So first, we're going to find 1%, as we've done in previous problems. So I'm going to round 639 to 640. So I have 1% of, so 1% is 1 out of 100 times 640. And I'm going to put 640 over 1. 1 times 640, that's 640. 100 times 1. 100 times 1, that's 100. Since I have 0 on top and bottom, I'm going to cancel out. All right, 64 divided by 10 is really 6.4. And I really can't have 6.4 of a student, so I'm just going to go ahead and say it's about 6. I'm going to take off the 0.4 because it's less than 5, and I'm going to cancel out. And out of 640 students, about 6 of those represent 1%. So 6 is about 1% of 640. Now, we're going to figure out what 5/10 of that is. So 5/10 times 6, and I'm going to put 6 over 1. 5 times 6, that equals 30. 10 times 1, that equals 10. And 30 divided by 10 is 3. So, in retrospect, about 3 students out of 640 attended summer camp last year and this year based on the numbers that we're getting. And again, I got 5/10% because we changed this decimal to a fraction to make it easy to work with. And again, we found 1% of the number. And we did round it because 64 divided by 10 is like 60 divided by 10. It's 6 is about 1%. So we took 5/10 times 6, we got 30 out of 10, and 30 divided by 10 is 3. Hopefully you guys are understanding this video. If you have questions on anything, make sure you ask them in class. Like this video, make sure you smash that notification bell, and if you haven't yet, make sure that you do subscribe so you get any notification of when I post these videos. You guys did awesome today, and I will see you tomorrow.